Good day to you all. You are welcome to a pure mathematics lab. And we want to continue from where we stopped last week. Today we're going to talk about cyclic quadrilateral. Don't forget, in this class, we've talked about the angle, the straight line drawn from the center of a circle to bisect a chord, which is not a diameter, it's a right angle to the chord. We've talked about the angle that a chord sustains to the center of a circle is twice that of which is sustained at any remaining point of the circumference. We've talked about the angle of angles in the semicircle. Angle in the semicircle is a triangle. We've talked about angles of the same segment are equal. But now today we want to talk about cyclic quadrilateral. Before we continue, don't forget to subscribe, to like, and to share. Your comment is highly welcome too. Cyclic quadrilateral. What do you mean by quadrilateral? We all know the meaning of quadrilateral. As a quadrilateral is what? A shape that is having four sides and what? And a four angle. For example, if I have something like this. Oh, this is a quadrilateral. Because that what? How many sides? Side 1, side 2, side 3, side 4. And how many angles? Angle 1, angle 2, angle 3, and what? Angle 4. So it's what? It's a quadrilateral. But we're not talking about cyclic. The cyclic quadrilateral, meaning that what? The quadrilateral that is having all these four vertices on the circumference of a circle. For example, like this. All the four vertices on the circumference of a circle. You can see the first one here, the second one here, the third one here, the fourth one here. They are on the what? Circumference of a circle. Then this one as well is cyclic quadrilateral. What am I trying to say? Am I saying this is not a cyclic quadrilateral? And if I have something like this, look at this one, and if I have something like this, yes, it's a quadrilateral, but it is not a cyclic quadrilateral. Reason because it's not all these four vertices, they are what? On the circumference of a circle. So the cyclic quadrilateral means what? A quadrilateral that is having what in the circle, but its four vertices are what? On the circumference of a circle. Now, we want to prove something here. What do you want to talk about? We want to talk about, let me just assume we have something like this. Let me call this way to be what? X. If this one is X, and let me say this one to what? To be Y. Let me call this place to be center. Given A, B, C, D. Alright, what I now say is that AOC is equals to what? 2S. Reason what? Angle at the center is twice angle at the what? Circumference. So we are saying this is what? 2x. At the same time, AOC reflex is what? 2y. This place is also what? 2y. Reason also angle at the center is twice that of the what? Circumference. We've talked about that. So we can now say 2x plus 2y equals to what? 180 degrees. Reason angle at a point. Then I can factorize 2 out, 2 into x plus y to give us what? 180 degrees. By dividing both sides by 2, then we can say, to give us 360 degrees. 360 degree angle at a point. So you can say this one is what? 360 degrees. By dividing both sides by 2, you can say x plus y equals to what? 180 degrees. And that is why we are going to, that's another theorem that's saying the opposite angle of a cyclic quadrilateral are supplementary. That's why ABC plus ADC equals to what? 180 degrees. That's another theorem that is telling us that opposite angle of a cyclic quadrilateral are supplementary. Apart from that, I can still have a cyclic quadrilateral like this. I can have a cyclic quadrilateral like this. Given the cyclic quadrilateral like this, then I have something like this. Then I have something like this. I can still say this place is equal to this place. Let me have this one to be A, B, C, D, and E. A, B, C, D, and E. Let me quickly prove that. You see, let me quickly prove that for you. Alright, what we are trying to say is here is that let me assume this place is X. If this is X, then I can find this place. I can say ADC is equal to what? 180 minus x. Angle what? On the straight line. At the same time, ABC plus ADC. It's also equals to what? 180 degrees. It's theorem that just really say that opposite angle of the cyclic quadrilateral are what? Are supplementary. So from here I can say my ABC is equal to 180 degree minus ADC. From here I can substitute this into this. Then I can say ABC is equals to 180 degree minus this 180 degree minus x. And that gives us what? ABC equals to 180 degree minus 180 degree plus what? X degree. You can see that this and this will cancel. Then we have ABC to be what? X degree. Imply ABC is equals to what? CDE. And that's what that is trying to tell us, is that the exterior angle of a cyclic quadrilateral is equals to the opposite interior angle. Is equals to the opposite interior angle. Today, we talk about the cyclic quadrilateral. I've explained the meaning of a cyclic quadrilateral. That is a quadrilateral that is having all these four vertices on the circumference of a circle. And we've talked about theorem. The theorem is that the opposite angle of a cyclic quadrilateral are supplementary. And we've talked about that the exterior angle of a cyclic quadrilateral is equals to the what? The opposite interior angle. We prove that. So before we finish today, we're going to miss next time. Don't forget that the theorem we talk about today is what? The opposite angle of a cyclic quadrilateral are supplementary, and that follows that the exterior angle of a cyclic quadrilateral is equals to what? Opposite interior angle. Till next time we're going to meet and move to another theorem or another problem in mathematics. Don't forget to subscribe, don't forget to like and share. Thank you, Mishi Dostov.